Okay. 7.3, this is the one where sometimes people kind of hit the wall. So, again, when we look at it, appears to be a very long note. So there are examples embedded in with the double angle formulas that are worked out. It came from a textbook and is probably not as streamlined as how I would solve them. So even when I went through the notes, you know, I have to go back basically and teach myself this stuff because I haven't done it in a very long time. I kind of solved them a little bit differently than they did here. So I'm going to post these filled in versions with my solutions kind of on the side, which obviously I get the same answer. It's just the way that you maybe answer them is a little bit different compared to the way the textbook would. So there are derivations here. There are examples embedded in. Are they good? Sure. But they're not good for your first look at double angle formulas. So I would put that all aside and go back to them if you want. But I'm saying you do not need to go back to them. I'm saying the 4 examples that are embedded here as awesome double angle formula problems, again, Mr. Todd's wording, will be enough to get you going on the homework. Okay, so these have been added this year sort of as a way to try to give us maybe a little better head start on the formula that we would have had in previous years. So the double angle formulas are going to look like this. There's a double angle formula in terms of sine, and by double angle, it's talking about the 2 that's in here. So sine of 2 times some angle x, cosine of 2 times some angle x, tangent of 2 times some angle x. That's why it's called double angle. Sine of 2x and tan of 2x only have one version of how they can be simplified on the other side. Okay? Cosine of 2x has 3 different versions. Okay? And they're all useful in different ways, and sometimes it's your choice in which version you want to use, and it's really up to you. The middle one, I would say, is probably the most popular. So cos of 2x equals 2 times cos squared of x minus 1. That's probably the one that's used most often. But it's going to depend on the situation which one you're going to use. They're cutting the grass in Glenhurst, I can hear it. Okay, so what we're going to do here is we're going to look at 4 very different examples to give you a flavor of kind of a little bit of each of these and what's going to happen here. So the first one says, express cosine squared of 2 theta minus sine squared of 2 theta as a single trig ratio. So the first thing you have to notice is don't even look at the 2 theta for right now. They're going to put all kinds of crazy things as the angles. Don't get overly obsessed with the angle right away. Look at this and say, I have cos squared minus sine squared. Do you see anywhere in the double angle formulas a cos squared minus sine squared? Of course, you see this one. So let me write that for a second. I'm just going to say note. I know this. I'm going to write it the other way because that's what comes first. Cos squared x minus sine squared x is equivalent to cos of 2x. This is what we know. I just wrote the right side first. Cos squared x minus sine squared x is equivalent to cos of 2x. Fine. Now look at what I have. I have cos squared of 2 theta minus sine squared of 2 theta. And I want to know what that equals. Well, in this case, what is my x value? I have simply replaced x with 2 theta. Okay, exactly where x was, a 2 theta appeared. So on this side, exactly where x appears, I want to replace it with a 2 theta. Okay, so in the end, I have cos of 2 times 2 theta, which is just cos of 4 times theta. Okay, it asks us to express this as a single trig ratio. Is this a single trig ratio? Yes. Okay, so that was the goal. So it's just, the first example is just a matter of recognizing what double angle formula is and substituting where is necessary. So you have to recognize that the x was equivalent to 2 theta in this. So when you substitute it in to simplify it, that's where that's going to happen. Okay. It goes from not so bad to terrible really quickly. Okay, a lot of questions are going to ask you to use double angle formulas more than once. Might ask you to use a combination of double angle formulas with addition and subtraction formulas. So you are going to have to become very well versed in how these formulas work. So we're going to start with this one, and it's not necessarily an easy question. Rewrite cosine of 4 theta as a single angle theta. When I look at this, the first thing, really the only thing that's going to help you right now is the fact that this is definitely going to be some double angle formula in terms of cosine. So I've eliminated the sine one and I've eliminated the tan one, but I still need to do this. Okay? And basically what has to occur is I need to choose, I'm going to write this cos 2x for a minute. I have to choose one of these formulas that's going to make sense. Now, this is already in double form, and I want to move it down to a single theta. So I want to move it down to a single angle formula form. So it goes from double to single. Well, if I go over here, then I have a single, but it's in terms of cos and sine, which is a little complicated. So I'm actually going to choose this middle one. And for now, it really doesn't matter which one you choose. You could have chose the sine one. But like I said, that middle one's sort of the more popular one. So I'm going to say I need to use this formula and somehow get it looking like this. So basically what I'm replacing here, I want this to be 4 theta. So you're saying, how the heck am I getting 2x to 4 theta? Well, I'm making 2x be equivalent to 4 theta, right? I'm just replacing the 2x with 4 theta. That's all I've done so far. So if I over here write 2x is equivalent to 4 theta, and I just want to solve for x for a moment, divide both sides by 2, I get x is equivalent to 2 theta. So I think a better way of writing this instead of 4 theta is I want to keep the 2 here and just replace the x with the 2 theta. Okay, so it's still going to say 4 theta, but I'm just going to write it a different way. 2 times 2 theta. Okay, so this was cos of 2x. I'm trying to solve for 4 theta, but you'd agree with me that 2 times 2 theta is still 4 theta. I'm just writing it a little different way, because what this allows me to do, once I can see what x equals, a single 2 theta, then I can start analyzing this side of the equation. Okay, because when I had it listed as 4 theta, I didn't know what to put in for x. Well, now I know what x equals. So when I substitute it in for x here, I get cos squared of, what is my x value? 2 theta minus 1. Okay, so I have this so far, and you're saying, okay, great. But I need to write it in terms of just theta. This is still written in terms of 2 theta. So I actually have to apply the double angle formula again, which doesn't come without its own difficulties. One thing I would suggest is when you see the squared in there, remember that cos squared of 2 theta is really just telling me cos of 2 theta all squared. I still have a minus 1 over here. I still multiplied out front by 2. But if I do that, that allows me to apply the double angle formula again just to this. Okay, so remember, this is something we knew. This is just a general formula from up here. If I want to apply this again, now I'm looking at a situation where what does my x equal in this case? In the second case, my x just equals straight theta, right? Cos of 2 theta, cos of 2x. So x and theta are the same thing. And then when I make this substitution, I'm going to replace this cos 2 theta with 2 cos squared theta. Right, I've replaced, this time my x just equals theta, minus 1, and then don't forget the rest of this equation said I still need to square that, and I still need to subtract 1 on the end. But what I've done is 2 double angle replacements. First one, my x equaled 2 theta. I applied a double angle formula. Then I recognized that I was still in terms of a double angle, so I had to apply it again. So now I get to this one. This truly is the answer. Okay, this is written in terms of a single theta. It is not simplified. So if this question, which it didn't in this case, but if it at some point it says, and simplify, we would have to expand this out, which is not overly difficult, just a matter of algebra. So if I want to expand this out, remember that squared really means 2 cos squared theta minus 1 times 2 cos squared theta minus 1, all with a minus 1 on the end. And if I FOILed it all through, then in here I'm going to get 4 times cos to the 4 theta minus 4 cos squared theta plus 1, all minus 1. And then when I actually distribute it all out, plus 2 minus 1 is going to be plus 1. And that would be sort of the expanded version. But this is, in this, the way they wrote this question, this is equally as correct as this. It's not unless they tell you to simplify it that you actually have to do the binomial expansion. So you're really foiling. If you want to do FOIL in a couple more steps than I did, that's fine. But eventually you'll simplify by gathering like terms. And don't forget about this poor minus 1 that was hanging out on the end right till the very end. Okay, so this went from, recognize the formula, substitute, to quite a bit more difficult here. And they do one similar to this at the beginning of the note, which I think the solution they made was very hard to follow. So I've done my own on the side if you want to reference another one that looks like this. Okay, don't take these ones lightly. Like, it's definitely difficult. Okay, let's look at number 3, which is going to bring back some of our ideas about exact formulas. Exact triangles, I mean. 3, 4, 5, 5, 12, 13. I find those two triangles, we've never really been formally introduced to them, but they're ones that if you know about, it's not something in math that you have to prove every time. We don't have to use Pythagorean theorem if we know those triangles exist, and they exist quite often. Okay. Example 3. This is very similar to what we did yesterday. Sine theta is equivalent to negative 5 over 13. And again, they give us where this exists. On pi is less than or equal to theta is less than or equal to 3 pi by 2. So they tell us that. And I'll do in a different color. The other, oh no, that's all they tell us. So we want to, based on that, we want to calculate a couple of double angles. Sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, not so bad. So what we need to do again, just like we did the other day, is actually graph this and see where that exists. Well, it tells us it has to be between pi and 3 pi over 2. So if you don't know how to draw this with radians yet, get going. It has to be between pi and 3 pi by 2. Let's just chuck it there. This is our angle theta. Okay, remember it always goes from some stationary arm there. Okay, drop a perpendicular as we always do. And it says sine of theta, which is opposite, negative 5 over hypotenuse 13. Okay, those values we know. So when you see a 5 and a 13, right away you should go ding, 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 that's an exact triangle. It's the 5, 12, 13 one. So I know this is a 12. I also have to know based on its location that that's the negative x-axis, so it's going to be a negative 12. Once you have this drawn, it makes everything else much easier. So for instance, I now want to find out what sine 2 theta is. Well, sine 2 theta based on this formula is 2 sine theta cos theta. Well, this is no problem now. What is sine of theta? Opposite over hypotenuse, or y over r. We started calling it in grade 11. Cosine is x over r. And then we multiply all those together. We get sine of 2 theta is 120 over 169. No problem. So it's just a matter of applying this knowledge and then putting it into a formula. Now cosine, which I did in light blue up there, I'll do here. Cosine of 2 theta. Again, you can use any of the ones you want. I've already used this in example 1. I've used this in example 2. I might as well use that one in example 3. And again, doesn't matter. So here I do 1 minus 2. Now I have sine squared of theta. What is sine theta? Oh, we learned it right here. Sine theta is negative 5 over 13. Make sure you square that. That's what that squared means. So I get 1 minus 2, 25 over 169. Then when I actually do the algebra on this and simplify, I get 119 over 169. I'll leave that up to you. You can find a common denominator. Okay, and then the last one to find tan of 2x. That red doesn't work so well. Tan of 2x, I do, tan of 2 theta. I do 2 times tan of theta over 1 minus tan squared of theta. Well, I have to know what tan theta is, so tan theta is opposite over adjacent, negative 5 over negative 12, all divided by 1 minus negative 5 over negative 12 squared. So I get 10 over 12 divided by, and this in the end is going to be 119 over 144. And as a final answer, I get 120 over 119. Okay, the goal of this lesson is, can you substitute in the proper trig ratios? Once you get to this is a grade 9 math question. I'm assuming you can do those. Okay, so just be aware, this is not an overly complicated question. Look at the restrictions. That's kind of one of the keys of what quadrant is going to end up in. That'll help you figure out what all the side lengths are, x, y, and r, and then you can plug them right into the formulas and solve. Okay, that's a very fair question that wasn't too difficult. Okay, number 4 is where we decide whether you like this or not. People are generally, they either love trigonometry or they struggle with it. So if you think back to your grade 10 days and you just did SOHCAHTOA, sine law, cosine law, how simple, right? And now you've really amped it up in terms of difficulty, and we're starting to see sort of what it's going to look like on the scale of mathematics if you leave St. John's and go into something that's heavily math focused. Okay, example 4. Find the exact value and this is bringing back, every time you see exact, think special triangles. Exact value of cosine pi by 8. Ooh, pi by 8. Okay, pi by 8 is something we don't know anything about. What we do know about, and if you remember the special triangles, so let me just draw them out for a moment. On the side here, to remind you what was going on, we had one that was pi by 4, like this. Okay, we had another one that was pi by 6, pi by 3, pi by 3 is 60 degrees, root 3, 2, 1. Okay, these are the two special triangles we had. We are now dealing with something that's pi by 8. So if you look at the special, as soon as you see exact, you should think special triangles. When you see pi by 8, you're analyzing, I have a pi by 4, I have a pi by 3, and I have a pi over 6. Which one of these is most likely to be related to pi over 8? Well, I can't make something 3 and 8 be very similar, right? In the same way, I can't make 6 and 8 be very similar in terms of a common denominator. Okay, those are kind of ugly to try to analyze. But what I can do is make some sort of equivalency here. Okay, pi by 8 and pi by 4 are very similar. Okay, because what would I have to do to equate these? Like, to go from 4 to 8, I just multiply by 2. Well, if I take this and say, how are these exactly the same? I do exactly that. I multiply the numerator by 2. Would you agree that 2 pi by 8 is exactly the same as pi by 4? Right? If I reduce 2 over 8, that's 1 over 4. So now I have this interesting situation. I know that 2 times pi over 8 is equivalent to pi over 4. And this is what I want. I want to change my question so that it is somehow related to a special triangle. So I had to somehow relate pi by 4, pi by 3, or pi by 6 to pi over 8. And one seemed much easier to compare than the others. So once I know this, I get kind of excited because this 2 out front right away says to me, ooh, this is a double angle thing, right? 2 times an angle is equivalent to what I'm looking at. So I'm really taking a situation and making it a little bit simpler. Now the equation I'm going to want to use from over here is cos 2x equals 2 times cos squared x minus 1. You're saying, well, how do you know you want to use that equation? Well, this is going to take some practice in what you see, because in reality I'm trying to solve for pi by 8. But the double angle is coming from pi by 4, sort of. So when you analyze this situation, watch what happens here when I just say, basically I'm going to let our x be pi by 8. If I let our x be pi by 8, that means everywhere I see a pi by 8, everywhere I see an x, I'm going to replace with a pi by 8. This gives me a scenario where cos pi by 8 shows up in the double angle formula. Now it shows up on the right hand side. Right here, this is really pi by 4, right? Okay, so when I write the next line of this, I go, oh, well, 2 times pi divided by 8 is pi by 4. Well, now all of a sudden I know the value of cos of pi by 4. Cos of pi by 4 is 1 over root 2. Remember, I'm trying to find the exact value, and then over on this side of the equation I go, okay, this is saying cos squared really means cos of pi by 8 all squared. And now I'm looking at a scenario where I now have to solve for pi by 8, cos pi by 8. So I'm going to start bringing things over to the other side. I bring the negative 1 over, it becomes positive 1. Okay, so now I have this, 2 cos pi by 8 squared. How do I get rid of this 2 out front? I'm going to have to divide by 2. Well, before I divide by 2, I might as well make a common denominator over here. So I have 1 plus root 2 over root 2. If I divide by 2, it's the same thing as multiplying by 1/2. Okay, so now I have, distribute the 1 in, it stays the same here, over 2 root 2. And then how do I get rid of a squared? What do I do to both sides? Square root both sides. So this now just becomes cos pi by 8. So this is really the answer. 1 plus the square root of 1 plus the root of 2 over 2 over the root of 2. Now, in terms of what's going on here, now you might say, how come I don't put a plus and minus here? The reason you don't put a plus and minus here is because you know your angle is pi by 8. It's a kind of acute angle. So when you're looking at the CAS rule, anything that's pi by 8 is showing up in here. All things are going to be positive, so we don't really need to worry about the negative version. This is not in simplified form yet. If I wanted to simplify this, I would have to, again, under the root sign, I'm going to multiply both the top and the bottom by root 2 over root 2. So I get square root of root 2 plus 2 over 4. And really what you can do to even simplify this further is, what do we know the square root of 4 is 2. So we can take that out 1/2, and then the root of root 2 plus 2. Now this is a question, because it uses a bunch of insight and at the beginning kind of guessing for you on where you're gonna, what direction you're gonna go with the question. But when you see something that wants the first clue is, if you want an exact answer, you're gonna have to use special triangles. So right away you look at your special triangles and go, well, pi by 8 does not help me. Well, try to make pi by 8 into something that has something to do with a special triangle, which is where I right away recognized, oh, I can compare pi by 4 and make that equivalent to 2 pi by 8. That allowed me to use a double angle formula. That allowed me to get a cos pi by 8 that I could eventually solve for. So take a look. If you want to go back and look at the note now, it'll make a little bit more sense. But again, I'm going to upload the filled-in version. I didn't originally have the filled-in version uploaded. We kind of want you guys to watch the videos. But the filled-in version is not going to make sense, I don't think, unless you watch the video. So this is the majority of the unit. The next lesson is not overly difficult, 7.4. So if you can get through 7.3 by the end of the weekend, then next week you're really just looking at 7.4 on Monday, a little bit of review exercises, kind of the supplementary problems, and then I'm going to release the assignment Wednesday to be due on or around Thursday at midnight. So far I've been very lenient in when people are handing them in. I give you basically at least a week. I purposely hold back publishing the marks for a week so that anyone else that wants to hand it in can get it handed in. Okay, there is one solid due date. It's going to be June 18th or June 17th at 3 o'clock. I have to have everything in because I have to get report cards ready. But other than that, we're pretty lenient till I hand things back. Okay.